Welcome to today's lesson. We are going to look at the radian, angular displacement, and angular velocity. We start by defining the term angular displacement, and this one is the angle swept by the radius of the circular path. If you look at the diagram that we have here, we have this is the radius from this point to where we have PO, and it has moved from PO to P, so it has swept this angle that we have indicated as theta here. So in other words, this angle theta is what we are calling angular displacement. This distance PO and P is what we call the arc length, and this arc length is always denoted by letter S. So mathematically we can say that angular displacement is equals to arc length over radius, and our arc length is S over R. So we have this formula that when we want to get angular displacement, we always look at S, which is our arc length over the radius of the circle. Then we move to the definition of radian. This one we say that it is the angle subtended at the center of the circle by an arc length equal to the radius of that circle. In other words, we are saying angle theta in radians is equals to S over R. When S is equals to R, that is arc length is equals to the radius, then we have that angle theta is equivalent to 1 radian. We can also look at the angle subtended by the circumference. Remember, the circumference is 2 pi r. So we want to see the angle subtended by the circumference to the radius of that circle. So we say that our angle theta here is equals to our arc length is now circumference divided by the radius. But to get the circumference, we have that it is 2 pi r and our radius is r. This r and r will cancel out, so this angle theta will be equivalent to 2 pi radians. But we know that the angle subtended by the circumference at the center of the circle is 360. Therefore, it means that 2 pi radians is equivalent to 360 degrees. Then we move to angular velocity. This one is the rate of change of angular displacement with time. Remember, whenever we talk of velocity, we have to talk of displacement and time. So mathematically, we say that angular velocity is equals to change in angular displacement of a change in time. And this one is denoted by a Greek letter that we call omega. Therefore, we can say that omega is equals to change in theta, which is our angular displacement, of a change in time. If you look at theta, it's given in radians, and time is given in seconds. Therefore, the SI unit of angular velocity, omega, is radian per second. We can look at an example. A particle moving in a circular path covers 1 revolution in 10 seconds. Remember, 1 revolution is equivalent to a circumference. Therefore, angle moved in 1 revolution will be equivalent to 2 pi radians, and the time taken is 10 seconds. Therefore, angular velocity is 2 pi radians divided by 10. You get that it is 0.2 pi radians per second. We can look now at the relationship between angular displacement theta and angular velocity, which is omega. So we start with this equation. We have seen that for you to get angular displacement, we have that theta is equals to S over R, where S is our arc length and R is the radius. So if we divide this equation by t both sides, we have that theta over t is equals to S over R over t. If you look at theta over t and S over t, if we take small changes of those quantities, we shall have that change in theta over change in t is equals to change in S over R change in t. Looking at this term, change in theta over change in t is what we have called the angular velocity, and the change in S is the distance, the arc length, and over change in t is what we are calling the linear velocity. Therefore, we have that this is omega and this is v, where v is the linear velocity. Therefore, we can say that our omega, that is replacing now, where we have change in t over change in theta over change in t, we have omega, And where we have change in s over change in t, we have v. Therefore, our equation becomes omega is equals to v over r. And you can as well get that v is equals to r omega. That is after making v the subject of this formula. Then from there, we say that any object that is moving in a circular motion has both linear velocity in meters per second and angular velocity. So this is our circular path. If you draw a tangent that is moving towards that direction, that will give us the linear velocity. If you're wheeling a stone that is tied by a thread and the thread is cut abruptly, you will find that the object or the stone will fly towards that direction. That is linear velocity. But now also we have that there is angular velocity that is making that object move in a circular path. So in other words, any object that is having this kind of motion, circular motion, it has linear velocity and angular velocity. Then we continue with the relationship between angular displacement and angular velocity, and at this time we look at periodic time, and this is the time taken to make one complete oscillation. This is denoted by a capital T. So if we consider one revolution, and we know that time is always given by distance over speed, one revolution will be equivalent to the circumference of the circular path. And our speed, we have just calculated, or we have seen the formula of getting the speed. Therefore, if we take our circumference to be 2 pi r and our speed to be r omega, r will cancel out as that, and therefore our t, which is our periodic time, is 2 pi over omega. From this equation, we can be able to say that omega is equals to 2 pi over t. That is by making omega the subject of formula here. But remember that our omega is v over r. So the same equation, this one, where we have omega, we can put v over r, so that we can have another expression or another equation where we are saying t is equals to 2 pi r over v. But we know that frequency is equals to 1 over t. We come back to this equation. Frequency is equals to 1 over t. So where we have 1 over t, we put f. So the whole of this denominator will go because it will be covered by f. Therefore, our equation becomes omega is equals to 2 pi f, where f is our frequency. Then we look at an example. A turntable rotates at the rate of 60 revolutions per minute. What is its angular velocity in rads per second? We start by the angle made in one revolution. We have seen that it is 2 pi. Then for 60 revolutions, we have 60 times 2 pi radians. And the time taken is 1 minute, therefore it is 60 seconds. So we can say that angular velocity is equals to change in angular displacement over change in time. So we put our values here, we substitute in our equation. We have 60 times 2 pi, which is the angle, and then time taken is 60. You get that the angular velocity is 2 pi rads per second. Then we look at another example. A model car moves around a circular path of radius 0.6 meters at 25 revolutions per second. Determine its period. The 25 that is given here is our frequency. Remember, frequency is the number of revolutions made in 1 second. And we have seen the relationship between frequency and the period, that t is equals to 1 over f. Therefore, given the frequency, we can say that t is 1 over 25, so that we can be able to get that t is 0.04 seconds. Then part B, you are supposed to calculate the angular velocity. From our derivation, we have seen that omega is equals to 2 pi f. So we just multiply 2 pi times our frequency, which is 25. You get that it is 157.1 rads per second. Then finally, we look at the speed, that is the linear speed. Our linear speed v is equals to omega r, or r omega. So we just put our value here and our r, which is 0.6 meters. you get that it is 94.26 meters per second. Then we have a quiz. At every question, the answers are given. But if you look at the second quiz here, you're supposed to define angular or differentiate or distinguish between angular and linear velocity. It is important to evaluate yourself. Don't go back to the notes and then recopy. Make sure that the definition or the differences are coming from your head. Revise as much as possible before you attempt the quiz, and always note that practice makes perfect. Thank you, and let us meet in the next lesson.